All right, you are welcome again. Today, let's take a look at this problem under exact equation. Okay, now this is exact equation made easy. Exact equation made easy. Now let's go. We are asked to show that this equation is exact and we are to solve, right? Good. The equation is 2x plus y cos xy dx plus x cos xy dy is equal to 0. So we are asked to show that this equation is exact and we are to solve it, right? Good. So the first thing first is, what is an exact equation? By definition, a differential equation of this form, m of x comma y dx plus n of x comma y dy equal to 0. Any equation of this form, which is a differential equation of this form, is said to be exact if the partial derivative of m with respect to y is equal to partial derivative of n with respect to x. Are we together? Yes. So the part that is having dx, call it a letter m. The part that is having dy, call it a letter n. Differentiate m partially with respect to y. It should give you the same thing when you differentiate n partially with respect to x. So if you get the same thing, the equation that this m and n is coming from is an exact equation. Are we together? Now let's try it. So the part that is having the x is 2x plus y cos xy. We call it m. Then the part that is having the dy, which is x cos xy, we call it n. Now let's differentiate m partially with respect to y. Good. Now when we differentiate 2x partially with respect to y, it's going to give us 0 because 2x is a constant. Good. Now let's differentiate y cos xy partially with respect to y. So here we are going to apply product rule, meaning we are going to differentiate y partially with respect to y, multiply by cos xy plus differentiate cos xy multiply by y. Are we together? Yes, let's try it. When you differentiate y with respect to y, it's going to give you 1 multiply by cos xy. Then we have plus differentiate cos xy partially with respect to y is going to give you x, is going to give you minus x sine xy, minus x sine xy, then multiply by y. So here we're going to have minus xy sine xy. Are we together? Yes. Now let's go to the other side, which is n. We are going to differentiate this n partially with respect to x. So here we only have x cos xy. So we are going to apply product rule again, meaning we are going to differentiate x multiply by cos xy plus differentiate cos xy multiply by x. So when we do so, we are going to have cos xy minus xy sine xy. Hello, please, I want you to pick a paper and try this, okay? Good. Now, looking at these two derivatives we have, we can see clearly that partial m all over partial y is equal to partial n all over partial x. Hello, we see that these two derivatives are equal. So we say that this equation is exact. So now let's go further and solve. So the solution that we're looking for is the integral of m dx plus integral of n dy equal to 0. Meaning we're going to integrate m with respect to x, integrate n with respect to y. Okay, bring these two integrals together, then it will give you a function, which is the solution to the differential equation. Let's go. Our m is 2x plus y cos xy, integrating with respect to x, plus the other side, which is our n, x cos xy, integrating it with respect to y is equal to 0. So let's integrate. When we integrate 2x with respect to x, is going to give us 2x squared all over 2. Plus, when we integrate When we integrate y cos xy with respect to x, it's going to give you y sine xy all over y, right? Plus c. Then the other part of the integral, integrating x cos xy with respect to y, we're going to have x sine xy all over x. Then we have plus c, right? Good. Let's simplify. Simplify, we're going to have x squared plus sine xy plus sine xy plus c. So we see that uh, in these two integrals, we have sine xy. So these two that appears here twice is what makes the equation to be exact. This is what makes the equation to be what? Exact. So here we pick one of them. We have that x squared plus sine xy plus c is equal to 0. Hello. X squared plus sine xy plus c is equal to 0. So this is the solution to the differential equation 2x plus y cos xy dx plus x cos xy dy equal to 0. Thank you very much for watching. Let's take more examples.